have a makeup artist who can check this here. Welcome everybody. My name is Isidro. I work in the Center for Life Cycle Engineering and Management at Cranfield University. Today here we are at the Rail Innovation Test area at Cranfield University. Welcome. Here is where we'll do a demonstration today using our vehicle Warthog. Before I hand over to my colleague Mifta, I wanted to remind you that you can post your comments and questions at the chat box below.
Hello. So we are going to demonstrate a railway inspection and repair task today. So the main idea of this is to find a railway defect on the track and then then use some mimic action to simulate some repair action. As a demonstrator, we have the system. It contains a trolley, Warthog UGV, and also a manipulator. We have many sensors attached to it. On the top, we have a LiDAR. We have a environment camera, RTK GPS. Also inside the Warthog, we have a computer, IMU, and wheel encoder. In front of the Warthog, we have a UA10E manipulator. It has 6 degrees of freedoms. And at the end of the manipulator, we have a monocular camera for finding the defect. So the sequence of the demo will be the robot starts from the base position. The arm is in the inspection pose. Then the robot travels along the railway track looking for defect. Once it finds the defect, it will stop and do some mimicking action. So I will now hand it over to Gian, who will show how the demo is running.
Yeah. You have to be on the robot before Mifta finishes.
So thank you, Mifta. Let's start our demonstration. We can see the Warthog is ready for the camera on the tip of the robot arm is capturing the images and recording the videos for the track.
Hello everyone, this is Ade and I'm a researcher at Cranfield University. So I'll be presenting some of the autonomous systems in this robot. But before I do that, keep your comments coming in and liking our page. So we have the Warthog, which is an adaptable robot, and we have some sensors on board. Aboard is the LiDAR, which we use to send signals around the environment using laser beams. We have the environmental camera that pick up signals from the environment, the video imaging, and processes the imaging in the controller. So I'll be handing over to Mesume to demonstrate the GPS localization.
Hi everyone, my name is Masuma Rahimi. I'm a PhD student at Cranfield University at the Center of Life Cycle Engineering and Management. My research is about developing and implementing autonomous localization and navigation for the robotic inspection and repair system. The main component of this robot is Warthog from ClearPath company. This robot has a number of sensors, such as RTK GPS, 3D LiDAR, RGBD camera, and an IMU and a wheel odometer. As this robot is considered to operate on the railway track, localization is highly important. For localization, we mostly apply GPS sensor, but GPS is not working properly in railway environment because of different reasons, such as tunnels, dense vegetation, unavailability of the satellites, and many other reasons. So in this case, we try to use sensor for vehicle localization and apply trackside objects as references for improving vehicle positioning. Next, I will show a couple of videos in order to relate it to the on-track vehicle localization and navigation and off-track autonomous vehicle localization and navigation. This test is divided into separate phases. The first phase, it is supposed that we have GPS. The vehicle starts moving in order to reach to the goal location. And in RVs, you can see that localization and mapping are running through RTAP map. And in RVs also, we can see a graph base that are generated from the RTAP map. In the related terminal, we can see that the GPS location has been reached. In the second scenario, suppose that we do not have any GPS. So this is the case that the vehicle, the vehicle need to identify where and when to stop in order to identify the defect location. Here, the vehicle starts moving and use the trackside object as a reference point in order to specify the environments around the defect location and also improve the vehicle's location. Here we can see that by detecting the distance from the nearby objects, it starts publishing, and when it reaches to the defect location, the vehicle would stop.
Yeah, hello everyone. We're still at real life, Cranfield University. Keeps coming in. So I'll be explaining more about the sensor fusion here. So we have on board the LiDAR, the GPS camera, and as well the environmental camera. So all these signals all the sensors send signals to the ROS computer, and all the algorithms are programmed in ROS2. So ROS1, they're programmed in ROS1 to demonstrate GPS localization. I'm going to call in Gian, who's going to explain about obstacle avoidance.
Hello everyone, at Robot Life. I'm Jian Li. I work on the software development for this robot. This is our latest railway robots and automated bench trolley. It has similar feature as the Warthog robot we talked before. The main difference is it's railway ready. It has the wheels ready to go on the railway track without any conversion. Today I'm going to show you an example of collision avoidance with the LiDAR sensor. Our LiDAR works by sending beams 360 degrees to the surrounding environment up to 200 meters, so it can have a clear view of what's around you. Today's demo, the robot will travel to the end by detecting this obstacle, which is the fake policeman, and eventually slow down. It will continue moving when the obstacle is cleared until reach the end. Now the robot start moving. Now the robot detects the obstacle and stop. The robot will stop unless the track is cleared. Now we clear the obstacle, the robot continue moving. Hello, Robot Life. This is Jian. I will now repeat the job sequence again, but this time I'll show you the camera on the arm of the Warthog, so you can see what does the robot see. Now let's get ready. Now you can see the arm move itself. to get itself ready to the right position. Now the camera is pointing to the side of the track. Look for QR code.
Yeah, so the robot is moving along the track. So it's worth mentioning that the whole sequence is fully autonomous.
Plenty of time to do a 1-minute conclusion.
So you can see the camera on the robot arm is scanning the rear. The robot is approaching to the QR code. It detects the QR code. And this is just a mock-up test. So in real applications, the robot arm's camera can be replaced by the ultrasonic testing equipment or any other maintenance equipment. So the robot can do the inspection and maintenance work.
Thank you again for joining with us today to watch our demo. So in this demo, yeah, don't forget to comment below, and our comment section is open for everyone, and we are here to answer. So before concluding, let's tell about what impact is going for the railway. We know railway is a hazardous environment. Sometimes people have to work in rain, in adverse weather. If we can use this system, it will help and it will make the inspection system much safer. So thanks again, and don't forget to comment.
Mention that it has been tested in real railway scenarios.
Yeah,
Yeah. Okay. Looks like you were in a rush to finish.
no.
Okay. Yeah, this one was better. That was 13 minutes. So
Okay.
you can
So we need
extend
to
it a bit
extend,
more.
extend a bit more.
Poor guy spent the